Hello and welcome to an introduction to intake. In this talk, I will introduce the concept of catalogs and then go through a practical example of how to build one, how you would share it, how you would wrap it up into a package for distribution, and then finally a brief summary. There is quite a lot of material, so I will try to go at a reasonable pace. First of all, what do I mean by catalogs? Well, as a practicing data scientist, you already know that one of the most important parts of your job is to find the right data set to do the particular task that's in front of you. And often that is not as straightforward as it should be. And then indeed to be able to load that data set, and that can sometimes be tricky too. There are file formats out there that include various metadata about your data, such as data types, description of what it includes, the chunks that you can split your data into, etc. But more often than not, you're dealing with data where you know very little about what is on the disk and you need to do exploration yourself. And this is quite painful. Particularly CSVs are the dominant tabular data storage format, and that tells you very little. It usually just the names of the columns themselves. And there's lots of things that can go wrong. For example, the particular text encoding, embedded new lines. These are things that can throw off what you want to do, data types, and extra information about the data, such as where it comes from, what it's meant to be used for, when it was created. They're just not there. In fact, usually all you have to go on is the name of the file, which is really no information at all. Furthermore, data changes. You get new data sets and you need to know which one is which and how to find the right one. And they might even be in different data formats. So you want to be able to get on with your analysis. You want to be able to load your data into memory and do all of the things that you do to tabular data in memory. And you don't want to have to think about it. If you're the provider of data, you want to be able to let those data scientists load the data also without thinking about it, but know as much as possible about each data set. Intake is the package that I'm talking about today, and it allows you to address all of the problems that I just mentioned. In particular, you prescribe each of your data sets using a standard form that I will show you. You can save this into files. These files can be saved locally or remotely, and you can distribute them so that people can load the data exactly as the prescription states. You can update these prescriptions so that everybody always has the current best version of the code. But you can also version control so that people can see the history of that declaration. You can group these data sets into catalogs, and you can group the catalogs into further catalogs, so you have a hierarchical structure that people can navigate to find a particular thing that they're after. And you can package these using familiar Python techniques. Let's look at the example. Let's restart this and go to the top. Okay, we will use the intake package, obviously, and I have found 3 particular CSV files on the Plotly datasets repository, and we will be considering them. So first of all, I downloaded a small sample of one of these, and you can see it has 3 columns, one of which is datetime column called date/time, and 2 more which are floating points called latitude and longitude. This is actually easy to load, but it could be much harder. So we're going to first of all load this little subsample using pandas. This should not be a surprise to anybody. We include the fact that the first column here is supposed to be date time. When we do that, we see that we've encoded this text into this data in memory. That was easy enough. Furthermore, we can produce some nice outputs from this if we wish. So we use here the hvplot package, and it's going to plot these latitude longitude pairs onto a satellite image. This refers to Uber drop-off locations in the New York City area, and here you see Manhattan Island in the middle and rivers either side and more land and some drop-off locations which I have colored red. Okay, so that's the preliminary investigation. How do I turn this into a catalog? Well, here I have the intake variant of exactly the same loading command uses OpenCSV, and this is going to use pandas or Dask to load your data. We need to give it the URL, and we give it the further arguments like this, which in this case was just this data hang column. When we do that, we can use this S variable to load the data. In fact, let's just show that. And the important thing here is that whatever type of data you're using, it's always just .read or .toDask to get the Dask variant for those the way you can. .read gets your memory filled with data. And you don't need to know anymore. You don't need to know that this is specifically using pandas. It could be using some other third-party package to load the data. The API that the data scientist sees is consistent, and that's very important here. But having made this thing, we can look at a YAML representation. YAML is a convenience that we use a lot in intake. It's not the only way to describe these things, but it is the simplest one, so we'll use it for now. This is auto-generated from this line here. It basically contains the same information. It has an automatic name, which is just CSV. It has the arguments, which in this case is the passing of the column. It has the URL, and it has a driver, which is the CSV driver. That shouldn't be surprising. We can put this into a catalog, a file. So let's actually look at this file. I've added a couple of extra things here, in particular this plots block. I've also given it a description, which is convenient. The plots thing here is a very convenient way that if the aim of this catalog is to provide visualizations, as is the case here, then we can say, specify how we want those visualizations to be produced. So in this case, we want to plot points. This is essentially the same thing as we had above for this plot. We want points, latitude, longitude. It's going to be a geo protection. We're going to use this form of background images, and we're going to plot in red. Here we see exactly the same things. So when we load this and we do plots, we've called this plot.basic just for the sake of argument, and you can see it produces an identical thing. So this is the indication to you that I, as the data scientist, I want to share my data set. I can prescribe exactly how I want to load the data and how I want to visualize the data so that other people don't need to mess around with those things. They can directly get to the data, they can directly get to the visualization with simple one-liners like this. And it's very simple for each of these to find out what that data is. In this case, all I've given it is a simple description, but you can give a lot more information than that. So moving on to the whole data set, we remember that this was all taking place on GitHub, and there are in fact 3 CSV files. Let's use some file system trickery to access these. So I'm using the package fsspec, which is integrated into intake. I could create a file system, or I can just open the files directly. And we can see that they have these sizes. Now, I could also, so these are 56 megabytes each. That's not massive, but it's of an interesting size at least. I don't want to be waiting too long for these downloads to happen. I could also encode all of this information for the file system into a single URL. Now, you don't have to do this. You can provide the keyword arguments such as the organization and repository, and I also included a specific version in here. This is a GitHub tag, and it's very convenient. You don't want your data changing if you're running an example like this. Sometimes you do want the latest data, but in this case, I want to fix it to this particular version. And I've also added the fact that I'm going to cache these locally on first use, which is very convenient because it can take a while to download files. This is very important in some cases. Finally, I'm going to load this with Dask. This is just for the sake of argument to show you that it can be done. And let's have a look at how much data that is. So again, this was 170 some megabytes of data, and it's in fact 4.5 million rows. So that's not too bad, as you could call that intermediate data at least. It fits handily into the memory of this machine, but you can imagine how this would increase with the size of the files on disk. Now I've made another catalog file and we'll look at that. So this is more like the concrete thing that you might distribute. Still, we only have just the one data set in here. This is for the sake of the example, but it's the same things again. Now we have a more reasonable name. We have the same date passing, and we have this complicated URL here, which says we're going to use caching, we're going to use a GitHub file system with the Plotly organization, datasets repo, and this version. And this is the glob of the files that I'm going to load. And I specify that I'm going to store these files with the same names that they originally had rather than using a hashing scheme. And I'm going to store them in a directory next to wherever this catalog file lives. That's just for convenience. I have better description. I've included some metadata with my name here. And I include a more specific plotting block here, just the one kind of plot still. The most important thing here is that I used rasterize at the end. This is because now I have 4.5 million points. They won't plot very easily. You would just get a solid red blob of all of the overlapping points. So I use this to pre-process the data first. So let's have a look at how that looks. This takes a moment to run. Anyway, here we have it. So let's zoom in. This is the New York area. You can see Manhattan is clearly the most highly high density area for drop-offs for Uber. We have a logarithmic color bar here, so it's all very nice, and this is nice and interactive. So all the nice things that you might want. So we go back to the talk at this point, reiterate some of these points. If you're making your catalog, first of all, you do need to know how to load the data, because otherwise you don't know what to encode. So you figure that out. Then you make a spec, which in the simplest case is YAML. YAML is perfectly fine for when you're dealing with a smallish number of data sets. And it's very clear and human readable, and it really is good for version control because all the changes show up nicely there. We encode it, we can include plots there, metadata, we create a simple catalog, add all these details in. So our catalog just contained the one entry, and then we're done. Oh, but we can update it, which is very convenient. So here we had a CSV file. Maybe we decide to save a version of this in Parquet so that it's going to load more efficiently. We can do that, but still reference the same catalog file, and it will be transparent to the user. Now we want other people to use this. That was the whole point of doing this. Although it is useful for an individual to catalog your data in this way, it's far more useful when you share different people's data sets or your own set of data sets used by many people. How do you do that? Well, we created a file that contains all of the information that we need. We can send this file to people. And that's all you need to do. And that might be enough in some cases. Just email the file or your favorite file copying process. You could also put the file in a place where other people can see it. And that might be a corporate network drive. You can put it public or private on GitHub. You can share it with various drive sharing schemes. You can put it on cloud providers' key value store. All of these things work seamlessly with Intake. You can just run a server, which is going to serve this file up. If you have access to outward-facing internet connection, you can choose to do that too. That's all perfectly fine. You can also run an intake server, which we don't have time to go into here. And finally, you want to place your data sets and your catalogs into catalogs so that you can categorize them nicely. People can find the specific thing that they're after. And then you have to tell people about it. But this, I, again, don't have time to talk about. It can be quite involved. But if you're in a team at a company, there should be a way for people to know what catalogs exist. And that's all that I'll say about it here. If you're using this for the purposes of writing a blog to bring attention to your data, then of course, whatever Twitter or public thing that you might happen to use will work. Finally, we want to turn this thing into a package. This is very convenient because people already know how to install packages. So if you've ever done this before for packaging code, the process is essentially the same. You can use Conda for this. This is the pip avenue. It's very simple. I have a setup file in the same directory. It looks like this. I have a name for this package, a version, a description. Importantly, I need to specify the different things that this is going to depend on. It needs requests to load the data across HTTP, and it needs hvplot so that I can actually show this visualization. And it includes this block here, which says I'm going to associate the name Uber trips with the module Uber containing a variable called cat. Now, what is that? Where did that come from? Well, we have this file, Uber data. This is the module that is referenced here, and it contains just 2 lines, and that's going to just load this YAML file, as simple as can be. This could be very complicated, but this being just an example, I want to keep it simple. To install this, you can use pip. So you could run this in the directory, or if you actually went through the process of uploading it to the Python packaging index, which I'm not going to do now, then you could tell other people that they need to pip install like this. Indeed, you could have this as a requirement for other packages that you might want to release, and that gives you a very nice dependency versioning story. The version here is important. You can update this and have people depend on the latest version or a specific one. So once you've done this, if it has been pip installed, it now, again, appears in the intake built-in catalog, which is just called cat. There is this thing called Uber trips, which is the name up here, and it contains this one item, which is called Uber. That's from the catalog file itself. I can access this as intake, inbuilt catalog, Uber trips catalog, a catalog, subcatalog, Uber entry, which is the specific data set. I have a set of plots here. Again, this is exactly the same as we had before, and I can execute this plot and get the visualization after a couple of seconds of processing. Here it is. And I can zoom in just as before. So your data is now code. You can use existing methods to distribute it. This means that you are forced into giving descriptive metadata. All the readmes, all those good things should be there. You need to include the specific requirements for this thing to run. That includes whatever intake plugin it needs, whatever file system backend it needs, whatever plotting, visualization tools it needs, they should be there. And you can version it, so you can update it. People will get the latest versions. They will get whatever extra requirements they might need. This is a very natural way of working. You can upload this to Python packaging index, or you can create it into a Conda package and update it to your corporate Conda channel if you have one of those. And then people can use it. They don't even need to import your package. It's just there in the intake.cat built-in catalog. How easy is that? And now a brief summary. Intake makes the process of describing your data so that other people can load it, whether it's local, whether it's remote, lots of different file types. It makes this whole process easy. It gives a unified API to access the data. You get extra descriptions and metadata about it, and that includes the plots, which is very handy. This thing you can save into files, you can distribute the files, or you can do far more complicated things if you want to. Please read the intake documentation for what those things may be. And then the final thing I demonstrated was the simplest way that you could package this so that you can send just a package to people. They don't even need to see your code. They can just access the catalogs and data entries directly. That's it from me. Thank you very much.